There may be some desperation about summation notation, but with a bit of concentration, this question's quite nice. We're given a sequence in the question, and we have to use an algebraic method to find the smallest value of n such that this property in the question is true. The first thing I'd like to note is that un, the sequence, is not the same as timesing 25 by 0.6 and raising it to the power of n. The reason is there is no brackets around the 25 and the 0.6, but this is still a mistake I see all the time. Just think, the examiner wouldn't write it in this form if it could be simplified straight away. So now that you won't be making that mistake, let's try and work out what type of sequence it is. If you already know it's geometric, that's great. That's a really good piece of knowledge. But if not, let's find the first few terms and see if we can work out what the sequence is. The first term is found by subbing in 1 into here. 25 times 0.6, we're going to get 15. The second term will be 25 times 0.6 squared. That's the same as doing 25 times by 0.6 and then times by 0.6 again. The reason I've written it in that way is because I want to compare it to u1. So I want to compare it to the first term of the sequence, because we know that's 15 times 0.6. So we can see u2 is the same as u1 times by 0.6. That gives us the idea that it's going to be a geometric sequence. The next term will be 25 times 0.6 cubed. And if I separate it out in the same way, it will be 25 times 0.6 squared, which was u2, or 9, times by 0.6. So here we can really see that every next term is equal to the previous term times 0.6. So we absolutely can be certain it's a geometric sequence. So just to put that into words, this is a geometric sequence. And what we'd like is we'd like the value of a, which is the first term. That's just up here, first one in the list, 15. And the value of r, as I've talked about, is that 0.6 that we see everywhere here. Or 3/5 if you're a fractions person like me. Now we've got more of an idea of what the sequence is, let's work out what the next part of the question is asking. We've got 3 parts, 1 summation, 2 summations, and then an inequality. Let's take the first summation and see if we can work out what it is. So this is from 1 to infinity, and you have to translate that into s infinity. So these represent the same thing, it's just a different notation. The formula, which will be in the formula book, is a over 1 minus r. A is 15 at the top of the screen there, and r is 3/5. So we can work this out. 15 over 2/5 times the 5 to the top, 75 over 2. Not too bad. The next sum we'll have to do on a bit of an angle, but that should be okay. Again, it's about recognition. You have to translate this into Sn. And again, the formula is in the formula book. It is a times 1 minus r to the n divided by 1 minus r. I realize here that should be a capital N. So 15, 1 minus, we know what r is, it's 3/5. Replace all of these little n's with a big N. Going to multiply out the brackets. And you'll notice at the start of the question, I'm not timesing 15 by 3/5. The 15 is outside the bracket, the 3/5 is in. Going to times the numerator by 5 now, because it's a triple fraction. And to simplify the answer just slightly, I'm going to divide it by 2 and separate these two terms. Like this. Again, with a big N, if possible. So it's the first sum minus the second sum is less than 10 to the minus 4. So 75 over 2 minus this thing should be less than 10 to the minus 4. Which should be 0.0001. Now, if we expand these two brackets, making sure to do a plus for these two terms, we'll get this expression is less than the same number. And then, nicely, these 75 over 2's will cancel out, leaving us with 75 over 2, lots of 3 over 5 to the n, is less than 0.0001. If I now times both sides by 2, remembering that it should technically still be a capital N, then this is true. And now I'm going to divide both sides by 75, but I've reached my limit of what I can do in my head, so I'm going to get my calculator involved. If I divide by 75, then I'm going to get this horrific number. I'm going to leave it as 6 recurring, so I don't have to write all the 6's. Now, when you see something like this is no longer about sequences and series. We need logs here. There are lots of bases you could take for the log. I'm going to take 3 over 5. Just remember to do the same log on both sides. There's a funny thing with logs, which maybe I should explain in a log video, but the sign now changes between these two terms because 3 over 5 is less than 1. It's perhaps easier to see if you do log base 10 because a negative gets involved. But if you write it in this way, it's okay. You just have to remember to change the sign. We're using log laws now. So we're going to bring down the n like this. And then I'm going to do log 3/5 of this number. I'm going to spam the 6's and the calculator should know what I mean. Now, log 3 over 5, 3 over 5 is 1. If you're not confident on your log rules, feel free to go back to the log videos. So n is bigger than 25, 0.12, blah, blah, blah. So n must be 26 because it's the first value that's bigger. And again, it probably should be capital. Have a go at these two.